Alright, here for number 19, we are actually finding the limit as x approaches a non-finite number, so an infinite value. So we're not going to just be able to plug in the negative infinity in place of x. We're going to go back to our strategy that we talked about. We're going to find the highest power of x that's in the denominator, and we're going to divide each term by that highest power of x. So we're going to write this as the limit as x approaches negative infinity of, and we're going to rewrite each term but dividing by x to the power of 6. And now we're going to simplify each of those fractions. So we have the limit as x approaches negative infinity, and canceling here we end up with 2 over x to the power of 3 minus 3 over x to the power of 5, and nothing cancels from the third fraction. Here x to the 6 divided by x to the 6 is 1, plus, and we cancel out 4 of those, or 2 of those x squareds, or x's, so we end up with 4 x's at the bottom, plus, and this gives us 3 over x to the 5th, and this doesn't cancel, doesn't reduce. And then we're going to find the limit as x approaches infinity. And we're going to use our theorem that said when we are finding the limit of a term that has a constant on top of the fraction and then a variable in the denominator, then we are going to use that theorem to say that as x gets increasingly large, so as x goes to negative infinity, the value of the fraction, the output of the fraction would go to 0. So that would be 0, 0, 0. Of course, the limit of 1 would be 1. This would be 0. This would be 0, and this would be 0. So on top, 0 minus 0 plus 0 would be 0. Then in the denominator, 1 plus 0 minus 0 would be 1, and 0 divided by 1 would be 0. So the limit as x goes to negative infinity for this function would be 0.